Okay, so we're going to explain this 45, 45, 90 special triangle. And when you have a 45, 45, 90 triangle, it means that we have a right angle. It's going to be a right triangle. And the other non-right angles are going to be 45 degrees. So we have 45 degrees here. And whenever we have right triangles, we want to think about Pythagoras theorem, and Pythagoras theorem simply states that in a right triangle, the sum of the squares of the legs of the triangle is equal to the square of the hypotenuse. The hypotenuse is the longer side of the triangle. So here I'm going to, because they are 45 degrees each, that means that this length here and this length here are congruent. They have the same value. So let's call this S over here and S over here, and then we're going to put a question mark here because we want to find out the value of the hypotenuse. Your hypotenuse is calculated as follows: c squared equal to a squared plus b squared. So here our c is unknown, so c squared, our a is s, so it's going to be s squared plus s squared. So c squared is going to be s squared plus s squared, which is 2s squared. So now we need to find the value of c. So c is going to be the square root of c squared, and so we're going to also find the square root of the other side. So now we have c equal to, I'm going to break this up, it's a lot easier to work that way, square root of 2 multiplied by the square root of s squared. So this is going to be square root of 2 multiplied by s. So therefore c is s square root of 2. So that simply means that if I have a 45, 45, 90 triangle and I'm given the sides, your hypotenuse is going to be side multiplied by square root of 2. And if I have the hypotenuse given and I need to find one of the sides, then your side is going to be hypotenuse divided by square root of 2. Or you can simply say that this is the same as hypotenuse multiplied by the square root of 2 divided by 2.